All right, so today we're going to look at zeros and multiplicity, and we're going to have to factor, so hopefully you brushed up on your factoring if you needed to. Some of these terms, such as zeros and other things like that, they're not going to be brand new to you, I know, but I'm going to kind of bring all this stuff together, okay? All right, so zeros. Another word for zeros is x-intercepts, right? Okay, so the zeros, they are the x-intercepts of a function. What's another thing we could call them besides zeros? We're going to have to talk about it. Roots, good. Roots, solutions, zeros, x-intercepts. So, but these we're talking about zeros, but they're all the same thing. Or represent the same thing, rather. So that's here. I would have 3 roots, 3 zeros, 3 x-intercepts, 3 solutions. All right. So a polynomial function, just polynomial. So we're not talking rational functions or anything else. Of degree n can have at most n real zeros. But that doesn't mean that if my degree is 5, I have 5 real zeros. Okay, maybe I only have 3. And the key here is this word real, right? It does have n zeros, but only, but it could have less than that and for real zeros. Okay, so if I have an even degreed polynomial, doesn't mean that it's an even function. Remember, those are different things. An even degree polynomial has an even number of real zeros, or no real zeros. Kind of count. 0 isn't an even number, but that's how we count it here. And then an odd degree polynomial has an odd number of real zeros. So if I do have a 5th degree polynomial, I'm not going to have 4 real zeros. I'm going to have 5, 3, or 1 real zero, because it would have to be an odd number. Okay. So when we said zeros, roots, we also have the solutions, right? So the solutions to the equation f of x equals 0, right? That's how we solve it to get our roots and our solutions. There are the zeros of the function. They are also called the roots. So roots, solutions, zeros, x-intercepts. So if I get x equals c as a solution, so x equals 5, right? Let's say that I get that. Then that means that x minus 5 would be one of the factors, right? So if I get x equals c is a solution to the equation, then x minus c is a linear factor of the polynomial. So how do we find linear factors? Well, linear factors can be found by factoring the polynomial, right? So there's a lot of ways to find your solutions. I mean, if you got a quadratic, you could use quadratic formula. You've got other things besides factoring, but the linear factors, you find them by factoring, and just make sure when you're told to factor something that that's what you're actually doing and not doing some other method of finding it, okay? So, for example here, I have an extra example over here, and I'm not really sure why. But if we're given this, it says, what are the linear factors? So I need to factor this, right? What's the first thing I always look for? GCF. So this would be equal to x times x squared plus 5x minus 24. Then I get x out here, and I'm going to get 2 binomials. I know this would be x and x. This is negative, so the signs have to be different, so it would be plus and minus. And what would my 2 numbers be? Very good. Positive 8 and negative 3. Okay, so that's my factored form there, right? But it asks me what are the linear factors. Well, those 3 things I have over there, those are my linear factors, because each one of them would represent a line if I graphed it so my linear factors are x. Well, I don't have any parentheses there. X plus 8 and x minus 3. Those are my 3 linear factors. So then my zeros, I want to put them in there from least to greatest. It's going to be -8, 0, and 3. So all of that stuff I know that you have done before because you have factored, you have solved, you have done that. It's the terminology that you got to make sure you pay attention to and that you're doing the right things and know what they're asking you for. Okay? All right, of course my phone is ringing. All right, so starting with number 2, it says find the zeros of the function below by factoring. So it's my only option. I'll find the zeros and I'm going to factor it. So I don't just factor it and stop. Here's the other thing. If it says just completely factor the equation, bam, that's it. Make sure all you do is factor and you don't solve it. Okay, because that's how we get stuff wrong too. Okay, so I'm going to set this equal to 0. I'll factor out my x, and then that's going to give me 2x squared minus 5x minus 3. So when your a is not 1, it is takes at least one more step, maybe your thought process to factor it. There's different ways to do it. Do we all at least know grouping? Because you got to know grouping for other things. I don't know how y'all learned it, or that divide and slide method. If you do that, whatever. I'm not trying to change the way you do things. But if I was going to do this by grouping, 2 times a -3 is a -6. So I get 0 equals. I got this x out here. So I need 2 numbers. They're going to multiply to give me a -3 and combine to give, multiply to give me a -6 and combine to give me a -5. And the signs are going to be opposite. So that would be what? -6 and +1. There you go. So I'm going to have 2x squared, and then I'm going to split this up. -6x plus 1x, or I don't need the 1, minus 3. I don't guess I need a brackets yet either. So then that's going to give me, now I'm going to do my little grouping here. So this gives me 2x. This leaves me with x minus 3. Then I get plus 1 times x minus 3. So that 0 equals x times 2x plus 1 times x minus 3. Okay, so I factored it. That's completely factored. I don't get to drop that x off. He's important, right? I'm going to have 3 answers here. Now remember, this is odd. So I'm going to have an odd number of zeros or an odd number of solutions. So I either get 3 or 1. That's it. So get, my x's are equal to, my smallest one would be what? -1/2, and then 0, and then 3. Okay. Now, we're not going to do number 1, so I'm going to do something here. For those of you that factoring is, you get it, like you should at this point. Let's just say I wanted to factor this 2x squared minus 5x minus 3. If you really do have a good number sense in your head, then you should be at the point where you can do this. Kind of the only way I was taught, or anybody was taught back in the day, because there was no tricks or grouping or box or anything like that, was you just basically had to understand what was happening here. So when a is a prime number, but it's not 1, this process is pretty simple. If it was not a prime number, then you can do the same thing. It just kind of takes more thought here. So if this is 2x squared, I know one of these has to be 2x and one of these has to be x. The signs are opposite, so I'm not sure where the signs go just yet, but what I do know is that these 2 numbers right here have to multiply to give me 3. So my options are 3 and 1 or 1 and 3. And whether you actually write it down underneath it or it's just in your head, I'm just going to do that so you can see what I'm thinking about. If I think, okay, what if I put a 3 here and the 1 here? Then 2 times 1 is 2. 3 times 2 is 3. So if I combine those, I get 5. But at the same time, I don't think that I'm not supposed to be combining them because the signs are supposed to be opposite. I should be subtracting them. So if I did a 1 here and a 3 here, I'm going to get a 6 and a 1. When my signs are opposite, then I can get that -5. And since I want this to be a -6, this would be a -3 and a +1, and you can kind of do it that way. And for some people, thinking through that process quickly is easier than, or faster, and you just get better at factoring. But it takes practice. You can't ignore factoring. Okay. All right, let's look at number 3. All right, so this is a quartic, but does that mean it's going to be complicated to factor? No, I can treat it like a quadratic. So why don't you go ahead and factor this one while I do it, and I just won't walk you through it. Let's see if we can get this one factored. Okay, so I have it this far. Am I done factoring? No, keep going. What is this situation right here called? Where I can go from here to here? We're subtracting, and subtracting represents a difference. So this is a difference of what? Difference of squares, okay? So when I get here, if my goal was to just solve it, could I have said x squared minus 1 equals 0 and x squared minus 4 equals 0? And then solved it that way? Got the same answer? The answer to that is yes, if I remember to do my plus or minus. But it specifically said by factoring. So it's really safer for you to factor it all the way anyway. That way you don't forget the plus or minus. Then when I get here, I could list out 4, or I could do plus or minus 1, plus or minus 2. Okay? I will tell you in Delta Math, there's some teacher-made questions in there. And if there's little boxes for you to put a separate number in each, then you're not going to be able to do the plus or minus just because of the nature of how it's grading it. So be careful with that. There would be 4 boxes for that particular thing if that was the issue. And always put them least to greatest. Okay, we good? All right, so why don't you go ahead and factor number 4? Give you a chance to factor number 4. You good? Or what? Oh, okay. But you got it? Do we agree? Awesome. Don't forget your other parentheses either. All right, anybody struggling? Need some help? Here, the way I showed you right here to do this, I wouldn't suggest for you to try this way on that until you're more comfortable with this when a is a prime number, because since that's 9, it could be that you have 9x squared and x squared, or you could have 3 and 3, or you could have 1 and 9. There's just a lot more options, and especially if there's more factors, there's a lot more things going on that you have to take into account. So grouping just kind of keeps it all, and there's no guessing and checking or anything there at all. Okay. All right, what questions do we have? Anything? Factoring is huge, guys. The basic algebra skills to be successful in here and in calculus, that's what you got to have. I mean, kids in calculus will tell you, calculus is not hard. It's the algebra that's in it that trips you up. The concepts you can get. I mean, the concepts we're going to talk about today, you'll be able to get. The concepts are super easy, but you got to be able to factor to get there. Okay? All right, so let's look at number 6. Okay? So I need to factor number 6. And is there a GCF? No. Okay, and it's a cubic. So what I know then is I'm going to have 3 or 1 real solutions. And what kind of method should I use here? Grouping. It's kind of my only option, right? So that's why you have to know how to do grouping for stuff like this. So being able to use it on the other is good. You just got to split it up. So I'm going to group these 2, and I'm going to group those 2. And I always bracket them like that so I don't use the wrong number somewhere, which is something I would do. All right, so the GCF here, I know it's going to be an x squared, but what's the number that's going to go in front of it? 4. So I can factor out a 4x squared. So that's going to leave me with 5x minus 3, right? And then here, I have to factor out a negative, right? So then that gives me 5x minus 3. So that's good. So you should be able to finish this up on your own then. What questions do we have? Anything? We're good? We can factor? Yay, if we can factor, we're going to be super successful at a lot of things. If not, we need to go back and practice. Okay, so on to what we're doing with this right now. The multiplicity, okay? So new number, right? But multiplicity, if you have multiples of something, you have more than one. So the multiplicity of a 0 is the degree of its corresponding linear factor. Okay, so we looked at that when we were sketching the graphs, right? So it says find the zeros of the functions below and state their multiplicities. So we're doing the same thing, we just have to state their multiplicities now. Okay, so let's factor number 7. It's going to be 0 equals, I have a GCF, right? This gives me x squared plus 10x plus 25. Now, I can factor just like I had been factoring, which is absolutely fine. Or I have another option. So go ahead and factor this however you want to factor this, because it's not wrong however you do it. I mean, unless you do it wrong, obviously. But as long as you get the right answer and it wasn't luck, then you're fine. But go ahead and factor that the rest of the way. And I hate to assume things about people, but I'm going to assume everybody kind of did it one way, and then we'll talk about another way. because consistency is important, if you factor this just like you did all the rest of them, so you would get an x and an x, right? And then, okay, this is plus and plus, so then it would be 5 and 5, right? That's totally fine. Absolutely nothing wrong with that. But if you learn to recognize that this right here, if I take this 10 and take half of it and square it, I get 25. So that is a perfect square trinomial, which sometimes your brain isn't thinking that way, so you just factor it like this. But once you see that, and you're like, oh, look, I could have done that, whatever. That's usually probably what's going to happen, and that's fine. But then I write it as x times x plus 5 squared. Okay? So I have two linear factors. Okay? I have x and I have x plus 5. And x plus 5 is a double, so it's going to give me what's called a double root. So my zeros are -5, which has a multiplicity of 2, and then 0, which has a multiplicity of 1. Okay. These questions on Delta Math, there's not multiple versions of them, which means that if you miss it, you miss it. Okay, and I think I might have given you 2 shots on that, but I don't remember at this point. So just keep that in mind. Sometimes there's questions on there where you can't do it over and over again to get credit for it. But pay attention, because it's going to say the zeros are, and there's going to be blanks for those. And you have to put them in order from least to greatest. And then it's going to ask you for the multiplicities. Well, you have to have them in the same order you did the zeros. It's not complicated. You can't you just can't put it in their random spots. Okay. All right. Why don't you do number 8? Give you a chance to get number 8 done. And just as a little hint, factoring is way easier if your leading coefficient is positive. So I would factor out a negative x squared and not just an x squared to make my life easier. Okay, so do we agree with this? Did I give you enough time? Again, if you factored that x squared minus 6x plus 9 and you got to a step where you had x minus 3 times x minus 3, that's fine. But it becomes x minus 3 squared. So you have a 0 of 0, multiplicity 2, 3, multiplicity of 2. You agree with that? Yes? Yes, go ahead. Yes, exactly, because I would have, these are my linear factors, right? So I would set that negative x squared equals 0. So that means that x squared equals 0, so that x equals 0, and then, yeah, there's 2 of them because it's squared. Because I could also separate it out, x times x, and then set both of them that way. Yes. All right, anything else? Okay. So, multiplicity and graphing. So we want to write this in factored form. So let's factor that. That's going to give me, I'm going to factor out an x. That leaves me with x squared plus 4x plus 4. Okay, so I can take this, I can take half of it and square it. That gives me 4. So I know then that that's x plus 2 squared. So my factored form, f of x equals x times x plus 2 squared. So, when the multiplicity is even, what happens when we sketch this? When we have a multiplicity and it's even. We didn't call it multiplicity, but it was, what happened when we were sketching those graphs? And what? Sorry, I can't hear you muffled. Be going up? Oh, okay. Yes, so if the whole function is even, then it would be, yes. But if I have a factor that has an exponent greater than 1 and it's even, what happens at the axis? It bounces, exactly. So what that actually means is that it is tangent to the graph. And we did say bounce, because when you're sketching, that's kind of what you want to think of. But it's tangent to the graph right there. When the multiplicity is 1, like this x, there's nothing special going on there, right? So it just passes through. Just kind of boring and just passes through the x-axis at that 0. When it's odd and greater than 1, what happens? Remember, we bounced when it was even. What do we do when it's odd? We wiggle. And what's the real word for wiggle? Do you know? Point of inflection. Very good. So this is a point of inflection. Which we did call a wiggle when we're graphing. So that means that we can sketch this graph pretty easily here, right? My zeros are 0 and -2, so I'm just going to go out to 3 here. And then my y-intercept's going to be 0 also, and then I'm here at -2. So overall, this is odd, which means my ends are opposite, and it's positive, so my end behavior looks like this, right? So I would go up through here, come back down and bounce at that 0, and go back up like so. Oh, I bounced at the wrong place, didn't I? Good Lord. I don't bounce at 0, I bounce at -2. It'll undo in just a second. There we go. All right, I'm sorry. I'm bouncing at -2. So I go up, I bounce at -2, and then I go back up through 0, like so. But notice on that one, when I did it wrong, I didn't catch myself, like, because it still looked like, oh, my end behavior, everything else was fine. So you still need to go back and double check yourself. Make sure you're bouncing at the right places, that you're intersecting. But notice this just has the multiplicity is 1. So it just passes through. You just straight pass through. It's not a point of inflection or anything. Okay, everybody okay with that? Good question?
Yeah. Okay, so I think it's positive. I thought
Right, but the whole function is not even. This has a multiple. The degree is 3, so the ends are opposite. That's why. Because when you're looking at the degree is 3, yeah. So the degree tells you the end behavior, and then the degrees of the factors, that tells you this stuff here. Okay, that's a good question. I can see where that can be confusing there. All right, so then let's look at this. So we're going to identify the zeros, their multiplicities, and describe the effect on the graph. All right, so I'm going to go ahead and, this is already factored for me, so that's good. So I'm going to go ahead and write them down so I can get them from least to greatest. Let's see, I have a 1, 3 halves, and -4. So I get -4 then what comes next? One. And then 3 halves. All right. So when I put them in here, I want to make sure they're in order. So I've got my zeros are -4, 1, and 3 halves. So the multiplicities. The -4 here has a multiplicity of 1. These both have a multiplicity of 2. So the effect on the graph, that's what we put in the blanks up there, that it passes through when it's just a 1. And yes, when it's a 2, it bounces when we're sketching it, but this is asking us, like, we're writing that down and that's not part of our answer. That's just for us to help us think about what we're graphing. Here, when it's actually asking us, we have to use the real words, which would be tangent on both of them. What questions do we have? We all good? Okay. So if you're good, you don't have any questions, do number 10 on your own. You got to factor it first. Are there any questions at all, or anybody need any assistance on anything? Okay, so the practice is in there and it's optional. I would suggest, however, if factoring is not something that you can fly through pretty quickly and easily, that maybe you go do it anyway for your own benefit, because I have it worked out. Although I have a feeling I need to go back and look. I have a couple of different keys worked out, and I think the one I put in there, I worked it a way that probably most I don't even do, but I was doing because I had some students that were doing that and I was trying to help them, so I worked the whole thing that way with like the divide and slide thing. But I have another one worked out differently, so I think I might switch that out here in just a minute. I noticed that this morning. But anyway, work on the practice if you want to. Even later, like after this is due, go back and do the practice if you haven't, because there'll be things you can factor and then the factoring worked out if you're struggling with it at all. Okay? And remember, on Delta Math, there's some questions that you don't get to do more than once. So, and I don't know that it tells you which ones they are. I'm not sure. Any questions at all? Alrighty. Then go ahead and get to